Hi, I'm Tobias, and this is a little intro and a little demo of the technology behind the CloudX project. What you see here are 16 ARM cores running at 250 MHz on a 14-euro FPGA. Yeah, that's right. 16 individual ARM cores running at an overall system speed of 250 MHz on a 14-euro FPGA. Each of the ARM core is toggling one bit through the GPIO, and each of the ARM core is running a simple Arduino Blink sketch. The difference is that you have a different initial delay, but the overall delay is the same. This helps me to easily detect a failing processor. So let's have a look at the technology used in this demo. The basic technology is system hyperpipelining, which multiplies the functionality of cores on a very area efficient way. I took the Amber core, which is an ARM compatible core from OpenCores. I did some optimizations so that it fits into a Spartan 6 LX9, and I extended it with about 80% of the thumb2 instructions so that I can run some Arduino sketches. The CPU fills about 90% of the LX9 and runs at 60 MHz. With system hyperpipelining, you can now run 5 individual cores at an overall system speed of 250 MHz, which is close to the switching limit of the FPGA. The only drawback here is that each individual core now only runs at 50 MHz, but now you have 5 of them. If you combine this technology with some sort of intelligent memory technology, which is also known as IRAM, you can distribute this 250 MHz system performance among 16 individual cores. You have a great flexibility to distribute the overall performance. You can have 3 CPUs running at 50 MHz, and if you want, use the remaining performance on 6 CPUs, for example. But most applications will use the 5 CPU version, running at maximum speed. For example, you see Linux on the first CPU, a real-time kernel on the second, and use the 3 remaining CPUs for interrupt handling. An additional technology step is event-driven programming, which heavily benefits from system hyperpipelining and the IRAM extension. So instead of executing an interrupt, you use one of the spare CPUs to execute the interrupt or the event. So the stack handling becomes obsolete, which improves the overall system performance. The next slides explain this in more detail. This slide shows that what has been a single core implementation so far is now a really cool multi-core environment. And don't forget, everything still runs on the same FPGA. So a few words about the event-driven programming. Usually a single core stops the execution of the program when an interrupt occurs and the stack is filled and the interrupt is executed. After that, the stack is emptied and the program continues. In the system hyperpipeline multi-core setup, a CPU is stored and the interrupt is executed on a spare CPU, which is started from the reset state and resetted once the interrupt execution has finished. Today's microcontrollers have an overhead, I think, of peripherals, bus system and DMA mechanisms. It sometimes takes you a few seconds to find the CPU in this schematic, sort of. Replacing peripherals with software is certainly not new. Also using a multi-core environment for this task, this already exists. Nevertheless, the purpose of the project is to demonstrate system hyperpipelining. Adding event-driven programming here makes a lot of sense, and we will see how many peripherals can be replaced with software. So let's summarize the technology of the CloudX project. System hyperpipelining is good for semiconductors because it reduces area and power and simplifies the system architecture. The user can run multi-cores, which is a lot of fun by the way, and has a much simpler programmer's model compared to other multi-core approaches. EDP, which is in this project based on SHP, allows you to replace peripherals with software code, which might lead to less devices per family and adds enormous flexibility. The other technology not mentioned so far is virtual prototyping. So for each of the project, a cycle-accurate model is generated to support, for instance, the emulation of robotics. So if you are interested in this project, follow Arduisimo on Twitter, go to cloudx.cc, or drop me an email to tobias@cloudx.cc. Okay, that's it so far. Goodbye.